welcome to the second video on analyzing quadratic equations using the discriminant. Today we're going to be looking at another case of quadratic equations where we only have one root or one answer or one solution to the quadratic equation. So in the previous video we looked at a situation whereby the quadratic equation we're trying to solve, ax squared plus bx plus c is equal to 0, has no answer. And we said this happens because the solution to a quadratic equation is given by this formula: x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, which you all know. And if this gives us the answer, we sometimes have a problem that the number underneath the square root can be negative. And if that number is negative, you can't take the square root of a negative number, so this entire thing becomes wrong. So your quadratic equation has no solution. Now today we're going to look at a special case where the quadratic equation has only one answer, which is another case as well, which you probably haven't bumped into. Again, the only cases you've been bumping into at this point are solutions which have two distinct answers. So these two new concepts of having no answer to a quadratic equation and having only one answer to a quadratic equation are a bit novel. They're a novel idea to most of you guys. So the simple explanation is, if you come underneath the square root here, what happens if b squared minus 4ac is equal to 0? What happens if you have a quadratic equation such that when you take b, you square it, you subtract 4 times a times c, you actually get the answer 0? Well, what's going to happen is that if the discriminant d is equal to 0, then b squared minus 4ac is equal to 0. Remember that d is just the discriminant. So what that means is, so x is therefore equal to negative b plus or minus the square root of 0 over 2a. Okay, this is what's going to happen. So the solution to our quadratic equation is going to be x is equal to negative b plus or minus the square root of 0. But if you analyze this a bit more, you'll realize that the square root of 0 is just 0. The square root of 0 is just 0. So what that means is x is equal to negative b plus or minus 0 over 2a. X would then be equal to negative b plus or minus 0 over 2a. Okay? Which would imply that x is equal to negative b over 2a. So this is what x would be. X would then be negative b over 2a. But this is just one number. So what this means is your answer to this equation is just going to be one number. You're not going to have two answers. You're only going to have two answers. If you work from this idea that x is equal to negative b plus or minus 0, your first answer, okay, our first answer, let's call it A1. Let's call it answer 1 would be negative b plus 0 over 2a. That would be answer 1. And then answer 2 would be negative b minus 0 over 2a. Because remember, this plus or minus here means one answer is going to be negative b plus and the other answer is going to be negative b minus. But negative b plus 0 is just b, negative b minus 0 is just b. So both of these is just going to be negative b over 2a. So what's going to happen is answer 1 is going to be equal to answer 2. So the two answers that you get for this quadratic equation are going to be exactly the same. And if the two answers you're getting for the quadratic equation are exactly the same, technically you just have one answer. You just have one answer. You just have one answer to your quadratic equation. So when you try and solve your quadratic equation, you're going to realize that you're going to have two answers which are exactly the same. Two identical answers which are exactly the same. And what that means is you only have one answer. So that's it. Some quadratic equations will produce one answer. You have one exact answer, and this entire thing here is the explanation. And remember, in my first video we discussed that the solutions to a quadratic equation, or the root to a quadratic equation, the roots of a quadratic equation, are simply saying, where is the y-coordinate of our parabola equal to 0? Where is the y-coordinate of our parabola equal to 0? and the x coordinate that we get is the coordinate where the y coordinate of that parabola is equal to 0. So if we are getting the exact same answer, what that means is that there is only one point on the curve at which y is equal to 0. So that's why our graph would then look like this, or, the other way around, look like that. Because there'll only be one point on the graph at which the y coordinate is 0. So anyway, that brings us to the end of the video on the explanation as to how come there are some quadratic equations which only have one solution. Until next time.